Okay, I work for Grid Dynamics. We do a lot of interesting stuff like cloud, continuous delivery, and so on, big data, analytics, internet advertisement, analytics. But the project which I'm working on is e-commerce search platform. So I'm talking about the e-commerce search, all issues about it, and so on. This talk covers one particular problem from e-commerce search, which everybody has in e-commerce, but it definitely has wider sphere. And these 3 days, every of these 3 days, we have several sessions about the same problem, about the updating field in the document, right? And we will talk about it again and again. We will stuck with the problem again and again until we will have updatable fields, true updatable fields in Lucene, which seems not really possible in the nearest future, or we will have doc values. Updatable doc values, that it will be a great step forward. Okay, we will see what the problem is with availability updates, review few approaches which you could come through already, review Solar internals once again to get familiar with how to plug in. We saw it already during these days, and check how all these solutions influence the architecture. Once a day, I had this search session on e-commerce site. It's a live site, true live shopping site. Bless you. I apply a filter, so I want to find T-shirt, something like this. So I apply a few filter. I see some T-shirt in search result. I go there. Oops. When I try to put it into my basket, it's not available. What's going on here? So this page is aware about this particular item is not available, but search result page is not aware about it. So it seems to me like we have data synchronization problem here, right? This page relies on the actual data from RDBMS or from key value storage and so on. But search results is a little bit outdated. Let's review the architecture draft. So how it works in general. It might be you need to update the slides to put Elasticsearch there because it's more trendy at this conference, you know. What we have in average e-commerce deployment. We have one huge index with products, right? And we have two different inbound data flow. One data flow is really rare bulk updates from CMS, where the merchandising teams build the product catalog, enter the product details, and push it into main product index maybe once a day or nightly. It's used for most of requirements. But we also has quite intensive data flow from inventory tracking system. When someone buys something from us, we need to count the number of items down, then some items became unavailable. So, and we need to reflect it into our index as soon as possible. That's actually a problem of availability updates in e-commerce sites. And from query side, right, what we do? To every user search, we just add the filter query, right? When we want to reduce scope of searches to available products only. But we don't need to find unavailable products, as I just did. Let's refresh our understanding of the core conceptions. What the filter query is? Filter query is nothing special, actually. It's just a single clause from query. It's a regular term query, which we load into memory instead of read it from the disk again and again. So we don't want to read it from the posting list, which resides in the disk, right? Let's read it into heap bitset and use it for filtering our search results. Right, come back to the architecture. Where is the main pain point in this architecture? Where is the most problematic piece of this machinery? What do you think? Thank you. The frequent updates, right? Because frequent updates is really, it's really hot and hard to handle. I'm sorry. We need to reindex whole docs until we can reindex single field, right? We got often updates, right? We need to replicate small data segments quite often, right? These small segments triggers merge sooner or later. It trigger merge event, and we need to be ready to all kinds of merges which can happen, right? And we need to test our system for all possible merges, right? To be ready to allocate enough memory and so on. So we need to bother with this low-level technical algorithmic performance stuff instead of delivering some business, right? Every commit, so after you update your documents, you have to do commit, right? Commit flushes your caches away, right? That impact your search latency. So during the holiday season, you have really frequent updates, right? And in this moment, when you really need caches to reduce your search latency, you need to flush them quite often. That's really painful. But we are really smart, right? And we reduce some workaround. We invent some kind of workaround. Right? What we can do? We can take this availability from the inverted index and put it into separate index, in the front index, right? It will use some much more easily updatable data structure, like RDBMS, key value storage, or even hash map resides in memory. So now we are able to handle updates quite much more easily, right? And then we supply the availability information, availability filter. We are adding filter query to every user request, right? It sounds reasonable, it's easy, it should work. But here's the problem, and problem in this filter query, because this query should work, and it worked when you prototype it at the weekend, right? It works great. But when you go to production scale, this filter query intended to have many primary ID terms, right? And handling this long filter is not easy. It's really expensive and costs you a lot of CPU. What actually costs? When you have several thousand of these terms in this filter, right? You spend a lot of CPU to parse. It might sound like odd or maybe ridiculous, but I saw query parsing as a hotspot in Profiler. So if you have a long filter, it's hard to parse. And it's mostly applicable for Lucene 3, when every term requires requires you to hit I/O. So you need to hit I/O to read the term dictionary. It mostly fixes it for Lucene 4, right? It's much better. We have a new codex proposed for primary keys, so we can load everything to memory. So the second item might work, might be not so applicable for Solar 4, right? It might be much more better there. But anyway, you should remind me that we have cache, right? That these filter queries should be cached and be bit set and heap, right? But this cache intended to have a low hit ratio because we always change this list of primary keys, right? The hit ratio will be low. We will search for this long query again and again. It impacts our latency. And also interesting fact that even if you have positive cache hit, right, so you need to evaluate the equality of two queries, right? And to return true from equals, you need to loop through all clauses, all query clauses, right? And when you have several thousand clauses, even this in-memory operation takes some time. And I saw it as a hotspot in Profiler. Might be really surprising, but it's true. Let's review both approaches, both architectures, and try to divide and try to get something valuable from the difference between them. So they're different just by the form of filter query, just the form of availability filter, right? But in fact, both of these filters are the same. They're just bit set. It's just two different forms of bit set. One of the most efficient, right? And another one is more expensive, right? What we can do, the solution is fairly simple and straightforward. We can just hold this availability bit set in the heap, right, and update it there. We don't need to bother with inverted index to run these updates, right? After that, we can apply this availability filter in query time. So everything should work, and it definitely works. So let's review the implementation details. But before this, let's come through the Solr extensions once again to get it by heart. In Solr, we can write our own queue parser, right? Register it in Solr config XML and specify to use this query parser, to hook it up in every query by using this local parameter syntax. Just put its name as local parameter. Then we also have nested query feature where we can call our query parser to parse any clause of an enclosing main query, right? So you can call your parser to parse single clause of query. Let's also refresh the core Lucene search routine, right? That's how Lucene searches. When we ask index searcher to search, it creates scorer and loops scorer through matched documents, and scorer put every matched documents into collector. Right? That's how it works. Solr has a really great feature which is called post filtering. Right? You can implement queue parser, which can provide the not just query but special post filter, which can create delegating collector, and Solr will inject the delegating collector between scorer and regular collector to allow you implement your own condition, your own matching condition, right? To select only those documents which you really need to select, which you really need to search. So in Solr we have mostly works out of the box solution for availability problem. It's called external file field and functional range query. So you can apply it something like this. So it works like you put availability into the plain text file, right? And then apply filter query by range of the availability. right? And I see two problems with this out-of-the-box approach. The first, it relies on full scan. So if I have many documents matched, but only few of them will pass the availability filter, right? I will full scan to match. It might be not really reasonable concern from the business perspective, but it's just a concern. And the second problem is that you need to trigger commit to reload this file. And this is absolutely strange. It seems absolutely strange to me, because I need to just reload this file. Why I need to flush all my caches away? It sounds strange to me. So what we propose to do? We go with our own query parser and nested query and hook it up by these syntaxes, which we already saw, right? Query parser works something like this. Solar index searcher can hold several caches, including the user caches. So if your plugin need to cache something, you should not bother with own singletons and listening to commits and so on and hooking commits, right? You need to just declare user cache in Solar config, and your plugins will be able to put everything what they need into this user cache. Okay, so availability parser find this bitset, availability bitset, and put it into Solar constant score query, right? And Solar constant score query is just a adapter for Solar top level bitset and Lucene queries API, right? When you need to handle update, right, you have special search handler which does not search, but handles simple JSON format and put it in as a new bitset. So it recalculates the bitset every time and put it into this cache. And we can do this for this task because we handle update in several minutes. So copy on write pattern works really well for this task. But if you will need to handle it much more frequent, right, we need to bother with atomic concurrent update, which will be much more attractive. But for now, copy and write works as we need. Okay, here is a simple JSON format for availability messages. Of course, the proposed design has its own issues, and the issue called stale entry cache. Cache entry. Solar has several caches, like query result cache, like filter cache. And if our query is included into one of these queries, then search result or filter calculated with using our query is derived from the bitset, right? And when the availability bitset is updated, right, this entry becomes invalid, they're stale, right? You need to somehow evict it. Right, so you can evict them all, but it's not always, it's not necessary. Like, for example, filter cache is intended to be mostly valid, because for filters you don't need to apply availability. You can apply availability for the main query, and you also can have several queries which don't need to apply availability constraint at all. So how to flush only those cache entries which are stale? So we propose to hold the timestamp in QParser, right? And put the timestamp into every query instance, right? When we handle availability update, right, we put the new timestamp into query parser, like it's a timestamp of last update, right? And after this, after we update timestamp in QParser, it will provide, it will create query instances with a different timestamp. And if we include timestamp into equal method, right, the new instances will not be equal to older instances, right? And we will have now positive cache hit, and in this cache, right? These queries will be reevaluated, and older entries will be evicted sooner or later. Let's review the architecture changes which we need to apply for going this way. We don't need to have a single point of update, right? We can handle updates on every searcher node, not standalone. We will lose some consistency and atomicity, but we win availability. Right? In shopping site, we can allow some sort of blinking. It will be really easy to catch and applicable. It's allowed for shopping site mostly, but you have more reliable architecture, and it's much more available than some highly consistent architecture. You also can, instead of push, you can subscribe all your search instances to some JMS topic, and they will receive updates from this topic. Right? It might be better than push model, where you need to know absolutely the endpoints of these nodes. Right? And there is some problem again with this approach. When you need to trigger commit during the day, right? Old searcher which searched for old generation goes off, right? And the new searcher is created, which holds new index generation, and it has no availability bit set. And there is no way to get the availability from the older searcher because bits are not cannot be used between different generations, right? What we can do, we need to persist availability updates somewhere, and when new segment arrive, we need to read the availability update from back to the beginning until, so we need to apply all updates which are older than the most old segment in our index. So getting this timestamp is not so easy, but there are a few workarounds, or you can always apply all updates, for sure, from end to beginning, right? But in this case, when you need to stop instance and start it back, or fire up new instance, you got the problem that you need to replicate this log, right? You need to replicate state of this log. So it's a little bit painful, and instead of bothering with replicating this log and durable subscription for bouncing your nodes, so we propose to use Apache Kafka, which is rethinking of messaging, which also which unifies the messaging error and persistence. So in this case, everybody can ask for redelivery availability updates from some time frame, so for last day, and then you need to start up new instance. You will just ask for redelivering update, and you will replay them on your index. That's all for this problem. So we touched, we've looked into problem itself, reviewed several approaches, reviewed Solr internals extension APIs again, and solved several problems caused by the proposed approach, and the review architecture changes which you need to apply to your cluster to handle these updates fast and efficient way. Here is shortcut for slides. That's all for me.
Any questions?
The inventory, how often does that actually update? Like, is it every second, or is it, like minutes?
We used to handle several thousand of updates, which came as a bulk. It comes as a bulk of updates in several minutes. So several minutes, we handle thousands of updates or few thousand, something like this. We have a kind of it might be really suspicious numbers for shopping site. Maybe some of them are really redundant updates, but we need to handle them anyway because of political issues. So
You aren't getting purchases every second, unless
New York.
you're probably not getting purchases every second.
Yeah,
unless you're
and
Amazon of.
And what we are looking for, that in few years we expecting the blowing up our catalog for 10 times or even for 100 times in number of data points, and frequent of updates will be much higher. So if we need to handle every purchase event from US-wide retail chain, it will be much frequent.
Sure.
Thank you very much, Mikhail. And that ends the Lucene track. There's still a closing plenary, which I believe is going to be in this room in like 15 minutes. But don't quote me on that. Just follow the mass of people and wherever they're going. Thank you, everybody.